Okay, so we are at topic 8, block 2. And based on the information that we had in topic 8, block 1 about Teresa and Terrence and their skateboarding situation, um, we can then look at this data table and complete it by putting in a process column. And so, what we want to do is create a process between the elapsed time in seconds that we see here and the distance in feet. So what we want to do is create a function rule that of course begins with, the y equals scenario, just like we've been doing in our entry tasks. So, and we could, by going through here, of course, decide, all right, how do we get from 0 to 0.7 distance in feet? And of course, this is our x column and this is our y column. Our input is the x and our output is the y. And how do we get from x to y so that we can write, at some point, we will be able to write the function rule in the next line down. So let me get down here. Okay. Uh, Absolutely. I see. It says, can we write the function rule? Yes, we absolutely can. And that function rule, and somebody has already, and I'll share that with you. Y equals 0.4x plus 0.7. Okay. Now, does anybody have a problem with that or not understand how we get that? Because if you do, that's perfectly okay. If we, of course, remember, we are looking for, in order to do this, we have to come up with what the rate of change is, or the slope, right? The rate of change, the ROC, which is the same thing as the slope, which is represented by the variable m for slope. Okay. And remember what that slope is. It is the change in y over the change in x. So we have to find what the change in y is. So how do we get from 0.7 to 1.1? Well, we add 0.4. Absolutely, Braden. We add 0.4. Is it the same for every one of these? It absolutely is. Every one of these is adding 0.4. So our change in y is 0.4. And what is our change in x? I'll do that in purple. Our change in x, well, let's see, it goes up just by 1, by 1, by 1, by 1. So our change in x is add 1, right? Positive 1. So if we're looking for the change in y over the change in x, that's going to be 0.4 is our change in y divided by the change in x, which is 1, which of course is just 0.4. All right, so that's the first part, 0.4. So if take any one of these, and it would be, in this case, 0.4 times 7. And then how do we take that and get it to 3.5? Well, we would have to add 0.7 because 0.4 times 7 is 2.8. And to get to 3.5, we would have to add 0.7. So 0.7. And that will work. And that will work for every one of them. And that's why we are able to come up with the function rule, which is right here. Y equals 0.4x plus 0.7. So then we ask ourselves this question here. How are the slope and y-intercept of the graph of the data represented in our rule? Well, what the heck does that mean? How are the slope and y-intercept of the graph of the data represented in your rule? What is that? What does all that mean? Can anybody tell me? The slope and the y-intercept. So what is let's start with slope. What is the slope? How is this represented in our rule? All right, somebody says that the slope is the 0.4, and that's multiplied by x. And what's our x, right? The x in this situation is our time, right? So for every second, our slope, the slope represents the amount of distance that is covered during the amount of time. So in this case, the slope tells us that that the skateboarder is going 0.4 feet per second. The change in y over the change in x, 0.4 feet per second. Okay? And the y-intercept, what does the y-intercept mean? The distance traveled per second. Yes, Carter, thank you. Yes, the distance traveled per second is our slope. The distance per second, 0.4 feet per second. And what about the y-intercept? What does the y-intercept tell us?
The y-intercept tells us where the line begins.
Yeah. In this case, the y-intercept tells us where the line begins, or in this particular situation, where the skateboarder was when they started. Correct? So at 0 seconds, the skateboarder was at 0.7 feet from the motion detector. So the y-intercept tells us where the line begins, and the slope in this case tells us how many feet per second. Very good. All right. So uh, the question then becomes, what is slope intercept form? Are any of you familiar with what slope intercept form is? It's okay, Kellen. Don't worry. That was excellent. So slope intercept form is a very standard. It's very standard form of writing an equation of a line on a graph. And when we do this, of course, when that gets written, slope intercept form is y equals, and we've talked about it a little bit, mx plus b. All right. And the m is, of course, the slope. All right. Slope is m. Slope. All right. And that's the change in y over the change in x, otherwise known as it used to be called our rate of change, and it still is. And b is our y-intercept. And b is always a constant. Yes. And the y-intercept, the b is the y-intercept. And that tells us at what point the line crosses the the y-axis when x is 0. And that's a really important thing to remember. It's when x equals 0, that's the y-intercept. So when that line crosses the y-axis, x is 0. How much is y? All right. So then when we look at question number 3, it says, identify the slope m and the y-intercept b of this equation. Well, it's really easy to see where the slope is, or the m. So m is the number that's being multiplied by x. That's our slope, our rate of change, the change in y over the change in x. And the y-intercept, the b in this case, is 0.7, because that's where that line hits the y-axis. Okay? No worries there, right? We doing okay so far? Okay, perfect. All right, glad to hear it. Now, this says we have to use the graph below for questions 4 and 5. Is the distance from the motion detector increasing or decreasing? I know I'm right at the end of class. As you can see from the graph, can anybody tell me, is the distance from the motion detector increasing or decreasing? Decreasing. Yes, yes, everybody, absolutely decreasing. Yes, it is. Now, when we look at this, the next thing says, what are the y-intercept and the slope of this graph? So what we need to do is come up with that. And we will continue this on Monday. So good news, no homework over the weekend. And we'll continue this discussion on Monday. Thanks for being here, guys. I appreciate it. Have a great weekend. And